Hello students, welcome to Study Out. This question is from Chemistry, chapter Thermodynamics. In the question, it is given that the reaction of cyanamide with dioxygen was carried out in a bomb calorimeter and delta U is found to be minus 742.7 kJ per mole at the temperature of 298 Kelvin. We have to calculate the enthalpy change for the reaction at 298 Kelvin. So this is the reaction of the question. We are going to use the internal energy and the temperature values for that. Let's solve the problem. So in the question, we have to find the enthalpy. And enthalpy, it's represented as capital H, is equal to U plus PV. U is the internal energy, P is the pressure, and V is the volume. So the change in enthalpy is equal to change in internal energy plus delta P into V. So based on the ideal gas equation, PV is equal to nRT. N is the mole, R is the gas constant, and T is the temperature. So if we substitute this PV value here, so we can write it as delta H is equal to delta U plus delta Ng RT. This Ng, delta Ng, is basically change in the mole at gaseous state. It means that when we have any liquids like here, so we are not considering this change, we only consider the change in the gaseous states. So we are going to use this relation to solve the problem. In the question, the reaction is given. This is the reaction. And we have to find delta H. That's the change in enthalpy. So in the question, it is already given that internal energy, change in internal energy is equal to minus 742.7 kilojoule per mole. It can be also written as minus 742.7 into 10 to the power 3 joule per mole. Because in the kilojoule, so we have to convert to joule. And the temperature is 298 Kelvin. Gas constant value is 8.314 joule per mole Kelvin. So let's substitute this value in the given formula. Delta H is equal to minus 742.7 into 10 to the power 3 joule per mole plus delta Ng. This delta Ng, we can find it. R value is given as 8.314 into temperature is 298. Now first find the delta Ng value. It is the change in the mole of the product and reactant, but it must be in the gaseous state. So here you see, in this case here mole is 1, the mole is 3/2, and here mole is 1 and 1. So the mole of the product is equal to mole of N2 plus mole of CO2. So the mole of the product is equal to 1 plus 1, it's equal to 2 mole. Similarly, mole of the reactant, it's equal to mole of NH2CN plus mole of O2. 1 plus 3/2, it's 2.5 mole. Now how much change in the mole? So delta Ng is equal to product is 2 minus 2.5 mole. So minus 0.5 mole. So we substitute the value of delta Ng here in this relation. So let's solve it further. Delta H is equal to minus 742.7 into 10 to the power 3 plus minus 0.5 into 8.314 into 298. So delta H is equal to minus 742.7 into 10 to the power 3 minus 1238.786. So delta H is equal to minus 742.7 into 10 to the power 3 minus 1.238786 into 10 to the power 3. Delta H is equal to minus 743.938786 kilojoule per mole. So this is the answer of this question.